Alright, 10.6. It was titled Tangents in your notes, but that was just a slight typo. It's actually secants, tangents, and angle measures. We're going to cover that all in this video. 10.6. In the objective, Buckingham students will find the measure of angles formed by lines intersecting on or inside a circle and outside the circle. So we're going to find out all kinds of interesting things that happens when angles are created by lines that go through a circle. In order to do that, we need to first talk about what a secant is. A secant is a line that intersects a circle in exactly 2 points now. So a tangent intersected at 1, but a secant cuts through it at 2 points. So we see this secant slicing through it right here. So we call that a secant, where a tangent, remember, just kind of touches the circle at 1 point here on the outside. Okay. A couple of interesting things here happen. Let's take a look at theorem 10.12. And it says if two lines intersect in the interior of a circle, then the measure of an angle formed is 1/2 the measure of the arc. Sorry, my A and arc is a little off. Intercepted by the angle and its vertical angle. Alright, so what we're saying here is, let's look at x here. X, and then this little thing here is theta. Well, let's look at x. X is the angle, one of the angles formed at least, by these two intersecting lines, and we could call them secants. And we know that this is also x, right? Because they're vertical angles. Well, we could take the arcs created by these intersecting lines, so we could take BC, and we could take arc measure AD, and we could add them up. So we could say, hey, BC plus AD, add them up, and then divide it by 2 or cut it in half, and that'll actually be equal to that angle x. So we could say BC plus AD divided by 2 equals x, and AC here plus BD here divided by 2 will equal theta here and here. That's all there really is to it. So that's kind of neat, and it's a little confusing, right, because we got to know these formulas, but it's not that bad. Let's take a look at this one. It says, find angle 2 if arc BC is 30 and arc AD is 20. All right, let's take a look. We'll zoom in, see what we can figure out. All right, well, I have two arcs here, and I have angle 1, and this is also going to be equivalent to angle 1. Well, these two arcs are 20 and 30, so the formula says I add 20 and 30 together, I multiply by 1/2 or divided by 2, it's the same thing, and that should actually equal the angle created there. So that's going to equal angle 1. Alright, so angle 1 equals 20 plus 30 divided by 2, and that's it. So angle 1 equals 1/2 of 20 plus 30 is 50, and 1/2 of 50 is 25. So angle 1 here is 25. So we can zoom in a little bit and just write that in there. And so that's 25, and now they really wanted us to find angle 2. Well, let's think about this. This is still a straight line, so angle 1 plus angle 2 have to add up to 180. So angle 2 must equal 180 minus 25. So 180 minus 25 is 155. So this angle here is 155 degrees. And that's it. That's it for a problem like that. Not too bad. Just add up the arcs, divided by 2. And that's when those things intersect inside the circle. So that's really important. When the secant lines or the lines intersect inside the circle, you're going to add up the arcs and divide it by 2. But we're going to find something happens differently when these lines intersect outside a circle, and we'll see that in just a little bit. But before we do, let's go on to theorem 10.13.
Alright,
Theorem 10.13 says that if a tangent and a secant intersect at the point of tangency, so here we have a tangent, here we have a secant, and they intersect right there at B, which is the point of tangency, then the measure of each angle formed is 1/2 the measure of the intercepted arc. So this angle here, ABC, is going to be half of this arc BC, and this angle formed here is going to be half of this arc BEC. And so they put that right there. Angle ABC is exactly half of arc BC. And this is really similar to an inscribed angle. Remember, we said inscribed angles are exactly half the measure of the arc they intercept. Well, hey, so is an angle formed with a tangent and a secant. So nothing too new to learn there. So let's play with it. If arc BC, so arc BC is 102, let's find angle DBC. Well, let's zoom into our drawing and fill it in and see what we can do. Okay, so they're saying this arc here is 102. Well, that means that this angle here is half of that, right? So we could just divide it by 2, meaning ABC is, I probably shouldn't have drawn that arrow, but ABC is half of that, which is 51 degrees. Okay? And that means we should be able to find the other angle here. And there's a couple ways we can do it. We could say, well, if this arc is 102, then this arc is 360 minus 102. So that's 258. And then that means that this angle here is exactly half of it, right? So we just do 258 divided by 2, which is 129. So that means this angle here is 129 degrees. Well, we could do that way, or we could have just said, hey, 51 plus 129 equals 180. So 180 minus 51 gives us 129. So there's a few ways we could have gotten that 129, but that's our answer. So let's fill it in. Angle DBC equals 129 degrees. Boom. All right, let's go on to the next theorem. Okay, this is theorem 10.14, and there's actually 3 examples of when this might be used, but they all really use the same formula. So let me read the theorem. It says if 2 secants, a secant and a tangent, or 2 tangents intersect in the exterior of a circle, then the measure of the angle formed, so this angle, and this angle, is the positive difference of the measures of the intercepted arc. Okay, positive difference. That means that, let me explain what that means using some numbers here. Okay, let's say I had numbers like 10 and 6. Well, 10 minus 6 is 4, but that's not the only difference between 6 and 10, because we could do 6 minus 10. Well, 6 minus 10 is negative 4. Well, which one of those is the positive difference? 4 is, right? And that's when you take the bigger number minus the smaller number. And that's always the case with these formulas, is you take the bigger minus the smaller. So take a look here. You got 2 secants. You're going to take DE minus BC divided by 2 or multiplied by 1/2. That's going to equal angle A. Here, DC again minus BC divided by 2 equals angle A. And last, arc BDC minus BC divided by 2 equals angle A. Now, one big thing with this problem here, arc BDC is a little bit interesting because BDC and BC normally add up to 360 in the situation with 2 tangents. So we should be able to find one arc from the other and then plug them both into this formula to get that angle. So we actually need even less information to solve a problem like this. So that's something to look out for. But these ones you are going to need at least 2 arcs or an arc and an angle to find the missing part. Okay, well, let's go on to the next page and the next problem. Okay, this problem just tells us to find x, so I'm going to zoom in a little bit. Alright, and it looks like we have an angle and 2 arcs that are intercepted by that angle. And we said the bigger minus the smaller, and then we just divide in half. Remember, when they intersected on the inside, we added them together, divided by 2. But when they intercept on the outside, we just do the bigger minus the smaller. So here we go. The biggest one is 120 minus the smaller, which is 50. Take it, multiply it by 1/2, and that's going to equal angle x. And that's really all there is to it. So x equals 1/2. 120 minus 50 is 70. And 70 times 1/2 is 35. That's it. You may want to try changing some of these numbers around and seeing if you can still do it. And that's most likely what's going to happen on your homework, along with a few other complications. But we'll go over that on Monday in class. So that's really all there is to that. Let's check example number 4. Okay. Basically, I'll let you guys read this if you want, but basically we have a satellite out here. It's orbiting around the Earth, and we know this angle is 11 degrees. We don't know what this arc is, and we don't know what this arc is. But we're going to try and figure out what is the amount or the arc measure of the world that the satellite can actually see at one time. And this is the trick here. We know, before we do anything, we know that arc PR, which we can represent with x, and arc PQR add up to 360. So let's just write that. Let's do that as the very first thing. PQR plus x equals 360. And so if I actually wanted to solve for PQR, if I wanted to know what PQR was, I could just subtract x from both sides. And there we go. PQR equals 360 minus x. Alright, this is important because as we go to put this into our equation, we're going to need something more specific than just PQR. But look, we have it. It's 360 minus x. So let's take a look. Remember, the equation says that the angle, which in this situation is 11, equals 1/2. The larger angle, which is PQR, or 360 minus x, minus the smaller arc measure, which is x. And now we're going to just solve for x. I'm going to have you guys finish this one out on your own, and so I recommend that you pause the video now and then check back with me to see if you got the right answer. So go for it. Okay, so I moved this equation. Well, first of all, I made it 360 minus 2x instead of just minus x. And then I moved this equation over here, and I got 11 equals 180 minus x when I distributed the 1/2 through. Subtract 180 from both sides, I got negative 169 equals negative x. Well, since it's negative on both sides, I can just multiply both sides by -1, and what do you know? I got x equals 169. So that's my answer. The arc measure of the equator visible to this geostationary satellite is 169. Alright. Last thing I want you guys to try and do, and I am going to answer this one on the video, but I want you guys to try it first, is to explain to me how you can write this out in words, how you're going to solve for x, okay? How are you going to solve for x? So give that a try and check back with me to see what the answer is after you've given it a shot. Okay, hopefully you said something about using the equations or the theorem from theorem 10.14 and said angle y has to equal 1/2 of arc WRZ minus ZV. From there, you should explain to me how you're going to just substitute all the known values. So y is 45, WRZ is 180, and ZV is 10x. Then you just use some algebra, distribute the 1/2, subtract 90 from both sides, and then divide both sides by -5 to get x equals 9. That's the kind of explanation I want to see from you guys. So that's the kind of higher level thinking I expect to see from you guys as well. So there you go. There's 10.6. Not too bad. I'll see you guys on the next video or in class. Bye.